t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval 0 is less than or equal to t, which is less than or equal to 80 seconds, as shown in the table above.
Okay, so we've got a table with some information. The rocket is moving in feet per second. Notice in some of the questions it asks you using correct units of measure. So on A part, what are you trying to find, Tyler?
The average, the average acceleration of rocket A.
Okay, how do we find average acceleration?
Did you do the value theorem?
The integral between 0 and 80? If you had a function, you could.
We're not getting
F of B minus F of A.
Okay, in this case, it's not really F, it is V. All right, remember, how does acceleration relate to velocity? It's the derivative, and a derivative is a slope. So, for A, if we took, thinking back to pre-calculus, the slope between the beginning point and the end point, that would give us the rate of change of the velocity, which is the acceleration. So, on A part, they've changed the, see if this will do. All right, you're going to find the average acceleration. So we could take the velocity at 80 seconds minus the velocity at 0 seconds over 80 minus 0. And remember, you want to show this to show that you understand what it is that you're doing. If you just go pick up numbers and you happen to pick a wrong number, then they couldn't give you credit. But if you show this and you happen to pick a wrong number, you might be able to get some credit on it. All right, part A is probably only worth 3 points. Each of these questions is worth 9 points. I mean, question 4 is worth 9 points. I think A is probably worth 3. They divvy them up differently depending on what's being asked.
Worth more credit for response or the multiple choice?
Probably more like 50-50.
You said most kids pass in years past in this class or in this class.
Wait, is this for a grade?
No, I didn't say that. It may be helpful for you to do this because you could see problems like this again.
Oh no, I'm just curious. Like when you're saying you're getting all these credit points, you're talking about for the test, the AB test, or your class?
She's talking about the test, yes.
On the test. But I will try, when I give you questions like this, I'll try to grade it pretty much the way they grade it. You get a point for this, a point for this, a point for this.
Yeah, I just don't know.
Okay, so you would get a point for having this, most likely. All right, so the velocity at 80 is actually, 49? Minus 5 over 80, which is 44 over 80. And
So 11 over 20.
how do I turn that off? There. So that is 11/20. And notice it said indicate units of measure. What are my units of measure? Feet per second squared. So you need to be sure that you have your feet per second squared there.
About what percent of the students passed the AP exam last year?
I don't know.
But was it like half of them passed and failed, or most of them?
It's different every year. You just never know. And I had more pass last year than I had previously, but still it wasn't 50%. All right, is there anything else that we might be missing on this question?
I mean, we did the units of measure, so.
Okay, we did the units of measure. Let me look and see how that was scored. This particular one was only worth 2 points. One for showing, wait, it's the wrong one.
That was velocity.
Hang on, I picked up the wrong. I must have laid it down somewhere.
It wasn't
up there.
It was acceleration because it was your finding the velocity on top and then time on bottom, so it's velocity over time.
Okay, this one was only worth 1 point, but then at the bottom there's a point for having the correct units of measure. So, but always show your work. I don't think when they did this one and they set up the grading scale that they were looking at this so much as they were the answer, but now they're looking at the work as well. If your work doesn't justify it, you don't get credit. Okay, let's look at B. It says, using correct units, explain the meaning of the integral from 10 to 70 in terms of the rocket's flight. All right, what does that telling us? That integral, what does that mean?
Between 10 seconds and 7 seconds.
What about between 10 seconds and 70 seconds?
The height of the rocket from the ground after launch.
Oh, and it also says we don't have to reduce
how
this stuff.
fast it's going. Feet per second.
If we the integral tells us how fast?
It's telling us the rate that it's accelerating between 10 and 70.
We don't have to reduce on this test, do we?
No.
Yeah, so we could just leave it in.
You could probably leave it at 44/80ths. All right, say that again, Curtis.
It's telling us the rate of acceleration.
The integral is?
You can find it with the integrals.
Distance.
Distance or position. So how does that relate to this particular problem?
Velocity and position is the integral of
Okay, so this means, this represents what? No, not when it's got the integral. It doesn't represent velocity. It represents position or distance traveled. When?
Over a period of 60 seconds from 10 to 70.
Okay, so this represents the distance traveled in what?
In 60 seconds.
In feet. Because it told us it's in feet. You want to be sure and put your units of measure from time equals 10 seconds to time equals 60 seconds.
Is travel spelled 20 or 2?
No, it's 70 seconds.
70 seconds, excuse me. Find my eraser.
Can you put sex like that? Or do you, like, they...
That should work. I mean, they know what that is.
Like you don't have to put time either, you can put T equals understand.
Yeah.
Sex? Sex? Let's say you abbreviate on the test.
Yeah, I understand.
You can, as long as your abbreviation makes sense. Okay, are we through with this question?
No.
What else does it ask, Andrew?
Use a midpoint Riemann sum with 3 subintervals of equal lengths to approximate Gaudiel function.
Okay. So if we're going to use a Riemann interval, a midpoint, with 3 subintervals, can we evenly divide this into 3 subintervals from 10 to 70?
Yes.
How?
You can do the interval of like 10 to 30,
And what's
and then like 30 to 50 and 50 to 70.
30 to 50?
Yes.
Are we going to 70 or? Okay,
70
30 to 50.
50 and then 50 to 70.
Okay,
Yeah, should have been
10 to 30, 30 to 50, and 50 to 70. That's right. Okay, so the midpoint of the first interval occurs at what time?
20.
At 20. The midpoint of the second interval?
40.
At 40. And the midpoint of the third interval?
60.
Okay, why is that significant?
Because they represent the average for that subinterval.
Okay, the average what?
The average feet per second whenever you take the
Average acceleration. That represents average acceleration.
average velocity.
The average,
Time.
well, it's going to give us the velocity at,
that point.
so if we were thinking about a graph and we did the midpoint, that would be the height of the interval. And what's the width of each interval going to be?
The length of the subinterval?
Okay, and how are these equal widths?
Yes.
Yeah.
What are the widths?
No.
30.
Yeah, no, 8, no.
20 seconds.
From 10 to 30 seconds is how many?
20.
20. From 30 to 50?
20.
And from 50 to 70? So we do have equal widths, equal subintervals. Each subinterval is 20. So if we do our Riemann sum, in other words, we're going to have to make the connection, and I'm going to go ahead and erase this to get it out of the way if I can. It may not let me. I don't think it will. Maybe I can just move it. Okay. If we take the integral from 10 to 70, this is approximately equal to, now we're going to do our Riemann sum. A Riemann sum is a rectangle. If you're to do a trapezoidal sum, it will say trapezoidal, which is half the sum of the heights times the width of the base. Okay, a rectangle is just length times height. Okay, so each one is 20, we said. You've got your chart. You might want to say the 20 times the velocity at
Wait, what? Why is it?
20.
Why would it not be 10?
Didn't we say the width of each subinterval was 20?
I thought it was 10 because it's 10 seconds.
It starts at 10, but
What was the subintervals that we came up with though?
between each interval. 10 to 30 and
30 to 50 if you made some.
Okay, so we've got 20 times the velocity at 20 plus 20 times the velocity at 40 plus 20 times the velocity at 60. One thing I want to caution you about, because I did this, I wasn't paying close attention, it's not 20 times 20 and 20 times 40 and 20 times 60. What is the velocity at 20?
22.
20 times 22.
And the velocity at 40? You've got it on your paper.
35.
And the velocity at 60?
44.
Okay, you can, this is
Add them all up and multiply by 20?
66 plus 35 is 11. You can't use a calculator. 101 times 20, which is, and what is this? Feet. Okay.
Wait, is 44 times 20 going to be 880?
20.
Probably, yeah, but it's easier to add them up and then multiply by 20.
Oh, yeah, that makes sense.
And it's feet?
And that is feet. Be sure and put your feet. All right, this one was worth 3 points. 1 point for the explanation that the integral represents the distance traveled from time equals 10 seconds to time equals 70 seconds. 1 point for picking up each of these velocities.
How do they want us to actually answer that? Okay, so we're just gonna have sheets of just lined paper, right?
Well, it won't be lined, but
Okay, just straight up blank piece of paper. We're gonna put the letters. Do they want us to box in the answer at the end, or is there any specific way of doing that kind of stuff?
you need to have your work organized so that they can follow it, because they're not looking for just the final answer. They're looking for all. You get points for all the work that leads to the final answer.
Gotcha.
I don't know why we did 20, 40, 60.
All right, because it asks us for a midpoint Riemann sum.
With 3 subintervals.
Okay, I'm going to pause. All right. William, read C for us.
Rocket P is launched upwards at an acceleration of 8 t equals 3 over square root t equals 1 feet per second. At time t equals 0 seconds, the initial height of the rocket is 0 feet, and the initial velocity is 2 feet per second. Which of the 2 rockets is traveling faster at time t equals 80 seconds? Explain it.
Okay, this is something you can do. Let's break it apart and think about it. It asks us to figure out which one's traveling faster. So we're going to be examining what? Speed, which is velocity, absolute value of velocity. What do they give us here? This function that they give us is acceleration. So how do we get velocity for rocket B? Antiderivative. Okay, so I'm going to move this off the, whoops. Move this off the screen. And we're going to do part C. We need, if acceleration is, what was it? 3 over the square root. Okay, so velocity, and this is for rocket B, velocity is equal to the antiderivative of 3 over the square root of t plus 1 dt. Right? Okay, we've got velocities for rocket A. We just need a velocity for rocket B. So we can take the antiderivative. If we move this 3 to the front, this becomes t plus 1 to the negative 1/2. You can integrate that. We're going to have 3 times t plus 1 to the 1/2 times 2, which is 6 square roots of t plus 1 plus c. Did it give us some initial information?
Yeah.
What did it tell us initially?
So height is 0 feet, velocity is 2 feet per second.
The initial velocity is 2 feet per second when height is
Height is 0.
0. Okay, so position is 0 when time is 2. What did I do wrong here? Oh, this is 4. Wait.
No, height is 0, or time is 0.
The initial height is 0, and the initial velocity is 2 feet per second. Okay, this is 2 when time is 0. So C is, what's C?
C equals -4.
All right. So our velocity function is 6 square roots of t plus 1 minus 4. And this is for rocket B. It asks us to find which is traveling faster at time equal 80 seconds. Do I even worry about the initial height? Do I need that information?
You do not.
Not in this case. So I need the velocity of rocket B at 80 seconds, which is 6 times 9 minus 4, which is 50 feet per second. The velocity of rocket A at 80 seconds is what? 49 feet per second. Which one's traveling faster? Okay. You've shown this. You've shown this. Rocket B
Wait, how do we know the first? What's the first one?
is traveling faster.
What's rocket A's?
You've got a chart.
Oh.
Okay. Okay, the other 2 problems are due after Easter break. And you need to be able to explain why you get what you get.